In this video, I'd like to talk about the math question of the day for Tuesday, August 15th, 2023. And with this problem, we need to find the inverse of this function f of x. And finding the inverse of linear functions is something typically seen in an Algebra 1 class, though you might see this in Algebra 2 or PreCalculus for the first time, depending on where you go to school. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, we can start working through this. And we need to find the inverse of this function. So before we do that, remember that the normal function essentially asks us if we know x is a particular value, what is the y value? If x is, let's say, 1, this function will tell us what the y value is. We just plug in 1 here for x. We get 8 times 1 plus 1, which is 9. So this is a coordinate on the curve of this function. But the inverse will essentially tell us the opposite. It will tell us if we know the y value, what the x value is. The inverse function will have us plug in a y value of 9 and will tell us that the x value is 1. So in some sense, the inverse function switches the x and y values. And that's going to be our general process. The first step is to get rid of the function notation and just use y. We can say that y is equal to 8x plus 1. And to find the inverse, what we'll do is switch x and y and then resolve this. We have that x is 8y plus 1. And to resolve this for y, we subtract 1 on each side. We get x minus 1 is 8y. And dividing by 8, we get that y is x minus 1 over 8. And once we resolve this for y, this is our inverse function. So we can use the notation for the inverse function, f with a minus 1 up here of x. And I should mention this is not f raised to the minus 1 power. This is just the notation we use for the inverse function. So one thing we can do is test our work now. This is what we think is the answer, but to know for certain, what we need to do is use a coordinate point. We know that on our function, on this curve, it goes through the point 1, 9. But in our inverse function, it will go through this point, but the x and y values will be switched. If this is truly the inverse function, then this curve will go through the point 9, 1. So let's test that. If we plug in 9 for this inverse function, we get 9 minus 1 divided by 8, which is 8 over 8, which is, of course, 1. And since we got back what we expected, we can feel confident that this is, in fact, the correct answer. Now, one other way to check your work is that you can plot both of these curves on the xy plane, and the inverse of a function has a special property in terms of its geometry. So if we quickly sketch this curve, it goes through a y value of 1, and it's very steep, so it will look maybe something like that, depending on how it's scaled. And with this curve, we can plot it quickly by rewriting it as y is x over 8 minus 1/8. So it has a y-intercept at minus 1/8, and then it is a very flat line. Its slope is only 1/8. But the main idea before we plot this is that inverse functions are symmetric. They are symmetric about this line here, which is the line y equals x. In fact, they will always intersect at this line y equals x, since this is the line where the x and y values are the same, meaning that if we switch them, it doesn't actually change the coordinate point. So if we roughly sketch this other curve, like I said, what we'll see is that they are mirror images about this line y equals x. And I did not draw this perfectly to scale, but that is the general property you will always see with inverse functions. So it's a way to visually confirm if let's say you plot these on graphing calculators, whether or not these functions are inverses.